Hey everybody! Welcome to today's deep dive, where we are going to explore the Distribute Points on Faces node. As usual, we'll cover all of the inputs, properties, and outputs. We'll then go into 3 quick projects using this node. We'll create some ground with grass and mushrooms. We'll add some bubbles in the shape of a sphere, which could be added to any shape. And then we'll create some randomly colored paint strokes to create some abstract art. So fire up your Blender and let's get started. We'll start in the Geometry Nodes workspace, and let's go ahead and create a new Geometry Nodes modifier. Next, we'll bring in a Distribute Points on Faces node. And we can see that many points were created across our mesh, the default cube. But we can change this input mesh. Let's delete our group input node, and we can bring in any mesh that contains faces, like our icosphere. Now our points appear to be more in the shape of an icosphere than a cube. Let's try adding a mesh circle and see what happens when we plug this in. All of our points disappear, and this is simply because our mesh circle doesn't have any faces onto which it can distribute the points. Let's plug back in our icosphere. We can remove our mesh circle as well. Next, we'll look at the selection input. Let's add a random value Boolean to remove some of our faces. And we can see that some of our points have disappeared. Let's go ahead and bring up a viewer with Shift-Control-Click, and we can bring our random value node into the value socket. Now we can see the randomization of the selection. The white portions will still contain points, while the black ones will not. We can go ahead and remove our viewer now, and we see our points once again. Now let's look at density, which will control how many points we see. Let's remove our random selection now so we can focus on the other inputs. Density is, specifically, the number of points that will be placed per square meter of each mesh face. Let's also briefly discuss seed, which, like on every other node, is the seed value for the randomization. Since randomization is not truly random, the seed value will determine where the points are placed. This can be adjusted to make the points more aesthetically pleasing. We can switch the distribution property from random to Poisson disk, and we'll see that Poisson disk gives us a couple extra input options. These are distance min and density max. The distance min is the minimum distance between points. We can use this to ensure that distributed objects that we place on the points do not intersect. As we bring the distance min up, we can see our points disappear. The distance min is the minimum distance between points. At the default of 0, this will not be enforced, and you are basically in random distribution mode. The density max will multiply the density by this value, except that it will not create more points than is allowed by distance min. If we reduce the min to 0, we can affect the density with max. The main output of this node are the points. This is generally used for an instance on points node. So let's bring one of those in. We'll add a cube as our instance object. We'll bring down the size of our cubes so they are not intersecting. And we can see that we have cubes where all of the points from our Distribute Points on Faces node were created. We also have a normal value available in the output. Let's go ahead and plug this into the rotation socket in the Instance on Points node. This is the normal from the placement of the point, and is a vector representing that normal. Let's bring in a join geometry node and look at how this compares to the base mesh. If we want an Euler representation of the normal, we can use the rotation output instead. And now our cubes are aligned with the faces of our icosphere. Let's remove our icosphere from the output and see how our cubes look. Now let's take a look at our first example of how we can use this node practically. We'll remove our base icosphere, and let's bring in a grid to represent our little plot of ground. We'll bring this into the distribute points on faces as the base mesh. Now let's add a set position so that we can add some variance to our grid plane. Let's also add a noise texture, and we're also going to bring in a map range. We'll hook up factor to value and bring the result into the offset. Let's also bring the grid into the join geometry so we can see it along with our instances. We'll bring up the size to 10 by 10 and the vertices to 60. Our ground looks a little choppy, so let's move these nodes over and add a set shade smooth node. Let's bring our density max down a bit. We're going to append a couple of collections, one for our grass and another for our mushrooms, and I'll make these available in my GitHub, and I'll add the link below. Let's go ahead and turn the visibility off at the collection level for both of these so we aren't seeing the base objects. Now we can grab our grass collection and bring that in for our instance here. We can delete our cube instance, and let's go ahead and copy our distribute points on faces and instance on points nodes. Now let's also bring in our mushroom collection. And we'll hook up our points and bring this into the object. Let's scale down these mushrooms, and let's also bring down the density. And we also want to check pick instance and separate children and reset children so that we only have one of our 3 mushrooms at each of the points. We'll adjust the density a bit more. And let's go ahead and switch our viewport to rendered mode. Let's bring up the min distance so that we can be sure our mushrooms are not intersecting. And we'll bring up the scale just a bit. Let's get our camera pointed at our scene. We'll also separate our grass instances with separate children, reset children, and pick instance. Let's route our ground out of the way down here so we have room for a set material node. And we'll just add a fairly generic brown color for the ground. And let's go ahead and add our set material node and bring in our ground color. Before we render, let's go ahead and bump up the density of our grass. And now let's render our image. And this is a useful technique for distributing items in a scene, especially where you want a random looking natural sort of distribution. Let's take a look at another example. We're going to create bubbles in a sphere shape. We're going to leave the sphere invisible, but obviously you could use this technique to create bubbles on the surface of any mesh item with faces. Let's start by getting rid of our ground objects. We'll go ahead and add our sphere. And we'll also bring in a distribute points on faces node. Let's go ahead and hook these up, and now we can see our points. We can bring up our density pretty significantly here. We'll make some room here, and then add an instance on points node. For our instances, we'll also use UV spheres. And let's scale down that radius until we get a nice bubble size. We'll leave these a little large because we're going to randomize the scale. Let's bring in a random value node and plug this directly into our scale socket. Let's go ahead and bring the min value up a bit so our small bubbles aren't too small. So let's head over to our shader editor to add a material for our bubbles. We'll add a new slot and material. Let's delete the principled BSDF, and we'll grab a mixed shader node. We want a pretty translucent material, so let's go ahead and grab a glass shader. We'll bring in a color ramp, and I'm going to use a fairly bright pink and then a light blue on the other end. We're also going to bring in a refraction shader, and let's set its IOR to 1.3. And to see it, we need to head back over to the Geometry Nodes workspace and set it. We'll add a set material node here, and we'll move over our output nodes. Now we need to bring in some lighting. We'll add a point light, which will come in directly in the middle of our sphere. Let's bring our wattage up to 500. Or maybe actually let's bump it up to 1,000. Let's go back to our shading workspace to adjust the world color. I'll darken this to black, and that looks really dark. So let's bring this lighter and just move around our color wheel until we find something complementary. And let's bring in another light. This time we'll add an area light. We'll bring that up on the Z-axis and scale it up. Let's come over to our object data properties and bring the wattage up. Let's try 400, and that looks a lot better. Let's adjust our camera a bit to center our bubbles, and we'll also zoom in a bit. Now let's go ahead and render our scene. And there we have it. And of course, you can change the bubbles color to white or whatever else works for your situation. Next, we're going to look at creating some paint strokes on a canvas. Let's head back to the Geometry Nodes workspace. And I've cleared out our previous project except for the Join Geometry and Group output. We'll start by adding a grid to our canvas. And let's update the size to a 10 by 10. We'll bring in our distribute points on faces and hook in our grid. Next, we'll add an instance on points node. And we'll go ahead and hook that up to our Join Geometry node. Let's add a cube for our instances. This will form the paint strokes for our canvas. I'm going to adjust the sizes here, 0.75, 0.95, and 0.005. And that's a little too wide, so let's take the X back down to about 0.04. And we'll update the verts to 8 across the board. Now we're going to bring in a random color for our paint strokes. So let's first bring in a store named attribute node. And we'll also grab a realize instances node to place before it. Let's bring in our index node and add that to the value for our named attribute. And we'll give our attribute the name rand. Now we'll come over to the shading workspace. Let's add a color ramp. We'll add a couple extra color stops in, and then distribute stops from the left. Let's add a nice bright yellow, and then we can set a few nice blue tones. Now let's set our color ramp to constant values. And then we'll bring it into the base color on the principled BSDF. Next, let's add a white noise texture and bring that into the color ramp. We'll add a math node and set that to snap. We'll bring that in and set our increment to 32. Usually, I will set it to the verts in our instance object. But here, we will get more than one color per instance. If you want one color per instance only, set this value to 296. Finally, we'll bring in our attribute and set this to the rand value we stored in our Geometry Nodes modifier. We'll name our color Random Color and head back over to the Geometry Nodes workspace to set our material. We'll add the Set Material node here and select our random color. Let's go ahead and bring our canvas, the grid, into the Join Geometry node. We'll add a couple of reroutes along the way to keep everything tidy. Let's add a Set Material node, and then we can set a material for our canvas. We'll head back over to the Shader Editor and create a new material. And let's just add a plain dark blue material. We'll name this material Canvas and go back over to the Geometry Nodes workspace. Let's set our material to our new canvas color. And we also need to set our viewport to rendered mode. Let's bring our density up a bit. The straight paint strokes give a neat effect, but let's try giving them some shape. We'll move these nodes over and bring in a set position node. Let's also add a noise texture, and we'll bring the color into the offset. Let's uncheck Normalize to bring our paint back to the canvas. And let's bring in a map range node so we can scale this effect. We'll change this to Vector, and to keep our paint strokes flat on the canvas, let's adjust the Z-axis of our 2 max to 0. Now let's set our camera back up. Let's change our noise texture to 4D and animate the paint. At frame 0, we'll keyframe the W at 0. We'll move to the end frame and keyframe this to 1. I'm going to bring down my scale a bit. And we can see the paint in motion as we play our animation. Now let's render our animation. That's going to wrap it up for our discussion of the Distribute Points on Faces node. If you've learned something or found this informative, please be sure to give me a like. And please consider subscribing if you'd like to support my channel. I hope you have a wonderful day, and I wish you a very happy blendering.